doing? Good day, Algebra. We are moving on into Unit 2. And this unit is all going to be about exponents. We're going to have a unit on exponents and exponent rules, then a unit on radicals and how to simplify radical expressions. Then we're going to just launch into all the other graphing stuff that we're going to do this year. So you have experience with exponents and powers before, okay? We're going to really go deeper into how do we combine exponent expressions, how do we simplify them, and so you got to get some terms straight first. An exponent and a power. What is the purpose of an exponent or a power? Why is it even a thing? Why is it even a thing, Ellen? Okay, so it's a notation for repeated multiplication. Okay, just like multiplication is repeated addition. It's a faster way, rather than writing 7 plus 7 plus 7 plus 7 plus 7, we just write 7 times 5. It means the same thing. Okay, rather than writing 7 times 7 times 7 times 7 times 7, you would write 7 to the 5th power. Okay, that power, that exponent is little. It's raised. It's how many 7s are being multiplied together. Okay, and that 7, what we have here, we would refer to as the base. Okay, the base is what the exponent is attached to. It's what is being multiplied. Anything else you want to say about that? Sometimes it's a number. It can also be a variable, right? But it's whatever is before the power. It's whatever that variable or that power is attached to. Okay. Then we have coefficients, right? Coefficient, like we talked about with variables. Who can remind me what the definition of a coefficient is? We've already kind of talked about it. Kylie? Right. In equations, it's a number that's attached to a variable. Similar thing here, but we're going to adjust it slightly. A number that comes, I should say, a number that is attached to a base. Okay? And here's the thing about coefficients. They are not affected by the exponent. Okay, I'll let you jot those notes down there. A number that is attached to a base, it is not affected by the exponent. So, for example, if we had an expression such as negative 10x cubed, okay, what part of that term, what part of that expression would be the coefficient, the base, the exponent? Aiden?
The coefficient is negative 10.
Coefficient's negative 10. Catherine?
The exponent is 3.
The exponent is 3. Kylie?
The base is x.
The base is x. So if we were to write this in expanded form, who can tell me what that would look like? Expanded form for negative 10x cubed. Negative 10x cubed. Crinkle. And when I mean expanded form, I mean write it as repeated multiplication. Okay, and we would typically put that coefficient first, but yeah, negative 10 times x times x times x. Notice how there's only one negative 10 there. We're not cubing that part of it. Okay, we're only cubing the variable, only cubing the base. Why would that be? Why would negative 10 not be a part of that multiplication there? Beckman? Why not, though? You're right, but why not? It's not next to it. Kylie? It's the coefficients. I'm looking for something kind of specific here. Aiden?
Because prognostic It's the exponents go first.
There you go. It all goes back to PERMDAS, right? You follow the order of operations, you'll be just fine in life. Everything in your life will be perfect. You just follow PERMDAS, right? And the reason, because exponents come before the multiplication, since we're multiplying negative 10 by x cubed, we've got to do this part first. Okay? The x times x times x. That comes first. And then we multiply that total by negative 10. All right. Good so far? Is this more or less review? Good. Okay. So the purpose of today is basically to practice with expanded form. Take a look at how parentheses affect exponent expressions, because they're a thing too, right? And just being able to identify a coefficient versus a base. What does my power actually do? What does it mean? And that's going to help us launch into some of the rules that we'll talk about later on in the week. Okay. So for each term below, identify the coefficient, the base, and the exponent. Write each term as an expression in expanded form. And then evaluate the term when n is 2 when you have a variable. So 2 times n to the fifth. What's our coefficients? What's our base? And what's our exponent? Because I have the gift of various colors here. I'll just underline my coefficient in green. I'll underline my base in blue. And I'll underline my exponent in red. If you've got various colors, you can do the same, or you can put arrows and just mark them with letters, whatever you want to do. But who can give me one of them? 2n to the fifth, I don't care which one you give me. What do you got? Alex? Coefficient is 2. More? Go ahead, Alex. You might as well. The base is the n. And the exponent is the 5, okay? So in expanded form, what is this going to look like? Kind of similar to the one we did up above an example, but expanded form. Long John. Yeah. 2 times n times n times n times n. Times n, I think. I lost count, okay? But 2 and then 5 n's all being multiplied together. Again, notice how there's only 1, 2. There are not 5 of them. That coefficient's not part of the power. And so now it says evaluate the term when n equals 2. So I'm going to rewrite this, and wherever I have an n, I'm going to substitute a 2. So ultimately, we end up with 6 2's all being multiplied together. Who knows what that is? I'll get to that in a second. Max?
Is it 2 to the power 6?
It's 2 to the power 6, but what's that actual value?
64.
64. How'd you solve that, Max?
I first just did 2 times 2 and then times that by 2.
Okay, so you kind of went just in order, just repeatedly. How else could you answer that with kind of not a math hack, but just maybe a little bit different way to think about it? Yeah, Will. Sure. Yep. Since it doesn't matter what order things are multiplied in here, you can kind of group them together. Some of you can just do the doubling over and over again. Some of you saw it as 8 and 8. You can multiply that. Mental effect there. But if you did use a calculator, if you've got a recommended calculator for this course, so if you could hold up your calculator, which most of you do have, how would you do? Max said it's equivalent to 2 to the 6th power. How would you do that in a calculator? Not just doing 2 times 2 times 2 times 2. But what's the button, Jack?
The X over 2 button.
That'd be to square something specifically. But since we're doing something in the 6th power, Joey?
Don't you press the A over B button?
That's for a fraction. That's for a fraction. Arlene?
LN.
Nope. That's for natural logs. Yeah. Algebra 2 for that one. Claire? No. Max?
There's Y and then an exponent of X.
That would be...
I
Yeah, you could. There's an easier, more efficient way to do it, though. Alex? No. So right above your x squared button, okay, there's a little caret that looks like this. Okay, right above the x squared button, there's a little up arrow. It's called a caret. That's kind of your to the button. So if you wanted to do 2 to the 6th power in your calculator, you'd press 2, obviously. Then you'd press that button. Then you'd press the 6. Okay? And that would bring you to 64. Right? I know. It's amazing. Money well spent. Money well spent. That calculator's only $5. You got 3. Yeah, $5. That sounds like an ideal. All right, come on back. 3, 2, 1. You are quiet. We did the next one essentially together in the example. Just replace x with n, and it's the exact same thing. The only thing that we didn't do is look at it with n being 2. So what would this one evaluate to be? What would this? Noah. Negative 80. Again, just remember there's only one negative 10 there, and then 2 times 2 times 2 is 8. Negative 10 times 8, negative 80. The next one, 3 to the 4th. Coefficient, base, exponent. What do we got? Who'd like to share? Who'd like to give us Crinkle?
81.
Okay. Coefficient, base, exponent. Let's label the pieces first. Okay.
The coefficient is it doesn't have one.
Nicely done. Yeah.
3 and the exponent is 4, and then you write 3 times 3 times 3 3, and then your answer is 81.
Yeah. Because our coefficients are always numbers, we kind of get into a habit of just seeing a number and thinking coefficient. That 3 is actually what the power is attached to, so that 3 would be a base. Okay. If you were pressed, say, no, there must be a coefficient. What is the coefficient? What would you say it is? It's not going to be 0, because that would mean that we're taking 0 times 3 to the 4th, which would make it 0. It'd be a 1. Okay. It'd be like 1 times 3 to the 4th, but if you say there isn't a coefficient, that's also true. Yes. You will be able to use a calculator on the test. Yes. Okay. Yes. Yes. Next one, n cubed squared. We get some parentheses going on here. Okay. What do you think? Coefficient, base, exponent, Aiden? So we kind of have 2 bases here. If we look at that exponent of 3, our base is n. But if we look at that exponent of 2, what's being squared, Kylie? Everything inside of our parentheses. So in a sense, we do have that base of n, but n cubed is a base as well, in the sense that that's what's being squared. Okay? So when we write this, we have 2 exponents as well here. We have 3 and a 2. When we write this in expanded form, we kind of have different levels here. We have n cubed, that's being squared, right? N cubed times itself. But then within our parentheses, we have n times n times n times n times n times n. Okay? So we have that what's being squared, the n cubed, so n cubed times itself. And then each n cubed is really an n times n times n. Do I need those parentheses there? No. Because we're multiplying everything, they're unnecessary. Okay? You can have them, yes. It wouldn't be wrong to have them. And what do we ultimately end up getting, Claire?
Wouldn't you do, so it's squared, or it's cubed and squared, so wouldn't you have 5 ends?
No. And this is why expanded form is very, very helpful. Because if you look at an expanded form, you can see, okay, what's being squared? N cubed times itself. each n cubed is 3 n's for a total of 6.
Where
Right?
did you get n cubed multiplied by?
Because that power of 2 is referring to the base of n cubed, right? What does squared mean? It means something times itself, right? What's being squared here is our parentheses. So whatever's inside the parentheses is being multiplied times itself. That's where the n cubed times n cubed comes from there, okay? And I'm actually glad you brought that up, Claire, because there's a rule later on down the line, I think it's CL 14, where we talk about, what's the rule when you've got a power to a power like this? What can you do? What's a shortcut? But knowing the expanded form, if you forget the shortcut, you can write it out like this, okay? Arlene.
On the test, do we have to make it the largest of the expanded form?
For this objective, yes. Yep, for the rest of them, once we learn the rules, no. But I do want to know that if asked for expanded form, you know what that is. Okay, so only for this objective on the test, you have to write it out like that. All the others, you can use the rules that we'll be learning. Sit flat, please. Last warning. Question? All right, and what does this end up being? Claire? 64. 2 times 2 times 2 times 2 times 2, blah, 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 64. Okay? Any on the bottom row that you want to talk about before we get to the second page? Any that stand out as something that you're not quite sure how you'd handle it? Alexis.
The negative n in parentheses and 4.
Yeah. So these two at the end here are very similar. One's got parentheses and one doesn't. How does that affect things? How does that affect things? How do those parentheses change what we're going to do here? Kylie, what do you think?
I think in the first one, like the answer would be positive, just like negative n times negative n to the negative n.
In the first one?
Yeah.
Okay. Christopher?
One of them is multiplying the negative n by itself, and the other one is just multiplying the n by itself.
So you're saying in one of them, the negative sign is part of the base, and the other one is not part of the base. Okay. Arlene?
I think that the negative for the second to last one is technically negative 1 times n.
Okay. That without parentheses, that negative sign in that third one there is not part of the base. Arlene's right in that this is just like a negative 1 out in front. It's as if this could be written as negative 1 n to the fourth. That negative sign is a coefficient, and it's a coefficient of negative 1. Meaning that when we write this out in expanded form, it is just one negative sign and then times n times n times n times n. Without parentheses, that negative sign is not part of the exponent. It's not part of the base. In the next one, with parentheses, now the base of this exponent is everything inside of our parentheses. I don't underline just that, it's the base there. Everything inside of the parentheses. So what's being taken in the fourth power? Negative n times negative n times negative n times negative n. So parentheses actually make a big difference here, okay, as far as what's your base and what isn't. Because now when we evaluate this, what does this third one end up being here? Negative 2 times 2 times 2 times 2. What is that value? Negative 16. Versus in the fourth one here, we've got negative 2 times negative 2 times negative 2 times negative 2. What does that end up being? Noah. Positive 16. Okay? Different answers. Right? So, I'm glad you brought that up. Pay very close attention to parentheses. Yes?
So does that mean in the first and the 4, it'd be 6n times 6n times 6n?
Right here? Yes. For this one, these parentheses make that 6n the base of that power of 3. So yes, it would be 6n times 6n times 6n. Whereas without parentheses, such as in that one, right, there's only one negative 10. Okay? With parentheses, it includes that 6. Sophie.
I put the last one in my calculator. It gave me negative 6.
So to put the last one in your calculator, I assume you put parentheses around it? Okay, it needs to have a parentheses around it, right? Because without parentheses, then it becomes this one, right? Which is negative 16. Okay, when you're using a calculator, you need to put exactly what the expression is. Because your calculator always does the correct order of operations, right? And if there are parentheses around something in your calculator, put parentheses around that thing. Questions? Comments, concerns, complaints, comments, congratulations, criticisms. Yes, sir.
On the next page.
Yeah. And before we get there, any questions on this? Good so far? Okay. Next page, Jack.
How do you do division on this?
Where are you looking? Oh, so don't worry about the division so much here. This is a lot practice of the first page. Where n is 2 is y straight. So in this first one, n to the fourth divided by y cubed. Oh, you're looking at for how to put this in your calculator?
No, I want to. Well, sure.
Well, because you have to write this in expanded form,
How do you do it?
right? So n to the fourth is n times n times n times n, right? And then we're dividing that by y cubed, which would be what? Y times y times y. Okay? So then plugging in 2 for n and 3 for y, we get 2 times 2 times 2 times 2. There's my n times n times n times n, right? Over 3 times 3 times 3. What do we get? What does our numerator equal? Beckman? 16. And what does our denominator equal? 27. That would be your answer. Okay?
Can you simplify it, or do you simplify it?
If you can simplify it, you definitely should. But don't give the decimal answer, especially one that is kind of nasty like this. You have to end up rounding it. The deeper we get into math, the more we care about accuracy. 16/27 is an exact value, whereas the decimal of this, which would be like 0.64 something something something, right around there, you have to round it, which impacts the accuracy. So leave answers in fraction form, unless it's like 0.25 or 0.6 or something. Then decimals are okay. Jackson, answer your question. Okay. Any others on here that you see that you want to go over, talk about as a group? Yes, sir. It will be, indeed. But you also have like 17 minutes to work on it, so. And it won't be due until Thursday. No, I take it back. It will be due tomorrow. Claire. Which one? Next one. So 10y to the fourth over 5n cubed. Our numerator, if we write that out in expanded form, we've got the 110, right? There's no parentheses there, so that 10's a coefficient, times y times y times y times y. And then in our denominator, we've got our 5 times n times n times n times n times n. That would be the expanded form. And similar to what we did in the last one, we're just going to plug stuff in, right? If y is 3, based on the directions up the top, 10 times 3 times 3 times 3 times 3. And then our denominator, 5 times 2 times 2 times 2 times 2 times 2 times 2. What does our numerator become? Callie? 810. Our denominator? 160. How can we start to simplify this? Long John. We could divide by 5. Yeah, they both end in a 0, right? Let's just cancel out the 0, which is essentially dividing by 10. And that leaves us with 81/16. And now we look at that and say, can't go any further, right? No, they don't share any common factors. So 81/16 would be your answer. Yes? No. No, as we go deeper into algebra, mixed numbers get used less and less. Basically, from this point forward, the only time you use a mixed number is when you bake. 3.5 cups. Pretty much it. Okay. Yes, Aiden.
Are we allowed to use a calculator on the homework?
You will be allowed. Yes, you can use a calculator on the homework. You can use a calculator on the test. You must write these out in expanded form. However, so all the work that I have here is work that you should have on your homework as well. Okay. I need to see the expanded form here. Okay. Anything else? All right. This is going to be homework for tomorrow. You will get your test back tomorrow, but it's a math days. We have shortened periods, so we'll correct this, give you your test, talk about the unit summary sheets, and then there won't be any homework tonight, or tomorrow night, sorry. It won't be any homework tomorrow night, due on Thursday for you. So homework tomorrow, due tomorrow. That's how you math.